Okay, we're going to look into the Huffman encoding, all right, in your computer science. Okay, and you're given this table, all right. So you have the characters on the top, and of course the Huffman encoding at the bottom. All right, you're also given a partially completed Huffman tree. And the question is to complete the tree by placing the remaining letters. So how do we handle this type of question? All right, because we did not draw the tree. Well, okay, the idea here is to look at what is given to you. All right, look at what is already given to you. All right, so let's say what we have in the tree. Let's say E. Okay, we have the E. All right, ignoring the case sensitivity. Okay, so E is given as 1, 0. So this must be 1. This must be 0. This line must be 1. This line must be 0. Then if I look at T, okay, T is over here. Again, ignoring the case sensitivity, is a 0, 1. So this one must be 0. This line must be 1. Now here is already I can see a pattern. Okay, it seems like the right hand side line is a 1 and the left hand side line is actually a 0. So I can test it out with something that is in the table. Let's say the P is in the tree is also in the table. So it's 4, 0. So 0, 0, 0, 0. Match. Let's try this one. Okay, H is over here. All right, 1, 1, oh, 0. So see, 0 is this left hand side, and we can further try with the Z. All right, just to confirm, again ignoring the sensitivity, the case sensitivity. 0, 0, 1, 0. Okay, 0, 0. Okay, so this side is 1, 1. See, you're going to the right hand side, and then the left hand side is 0. So now I can see a very clear pattern, all right, of how this tree actually work. Okay, so it will not be difficult to place the rest of the character, all right, such as your O, all right, your L, okay, and W. Okay, so you have your O, L, and W. So your O is 3, 1. So 1, 1, 1. See, your O is here. Your L is 0, 0, 0, 1. So 0 is this end. 0, 0, 1. L. And lastly, your W is 0, 0, 1, 1. So 0, 0, okay, then 1, 1. All right. Okay, so now the tree has been encoded. All right, so we have everything there. But the question has not ended yet. All right, there's still another part of the question. Let's take a look at it. Okay, so the question now further asks us, could this tree, the Huffman tree, be extended to include more letters? So if not, why not? So it's not just a yes-no answer. Of course, you start with a yes-no answer, but there must be a reason behind your answer, right? Which actually the reason is the one that get more point than a yes-no. Well, first of all, the answer is a no. Okay, excuse me. The answer is a no. All right, so I concluded a no, but I have not yet answered the why not. Okay, so no, why? Look at this tree. All these lines are the branches. Okay, they are the branches. And all these at the end, which is the letter, are the leaf or the node. Okay, some books actually call it the leaf, some books call it the node. Okay, doesn't matter. I call it the leaf anyway. All right. Is there any more space? Is there any more space on this tree for any more character? Well, you can see every N is already filled up. So there is no space for any more letters. That is why the answer is actually no. If I want to have more letters, all right, this tree has to be remodified. Okay, it has to be remodified itself. Okay, so it has to be changed. That is why the answer is no. All right, just by looking at the tree, just by looking at the leaf or the end nodes, there is no more space. All right, that's why the answer is actually a no. All right, Huffman tree, Huffman encoding is a little bit tricky, but not impossible to understand. It takes a little bit of practice, so just keep it up. All right, don't give up. Okay, just run through another few more examples. You will get the hang of it.